Welcome back, grade 10s. This video lesson 2C is a continuation of 2B, where we're going to work through two examples. So remember, the questions we ask is in which direction will the electrons flow between the two objects when they're in contact? And then the second one is, what is the total charge on the objects? And what charge will each object have after they've been in contact? And what is the change on charge on each object? And then how many electrons were transferred? So charge A has a plus 3.2 microcoulomb charge. Charge B has a minus 5.8 microcoulomb charge. So from which one will electrons be transferred? I can see that on B there is an excess of electrons, and on B there is a on A there is a shortage of electrons. So obviously then, when the two objects are in contact, when they touch, the electrons will flow from B to A, and the charge will spread evenly over the two objects. Now, what is the total charge on the two objects? The total charge is the sum of the charge on A and the charge on B. So it's plus 3.2 microcoulombs plus the negative 5.8 microcoulombs. So it's basically 3.2 minus the 5.8 microcoulombs. So the answer is a negative 2.6 microcoulombs, which, if you write it in terms of coulombs, it is negative 2.6 times 10 to the minus 6 coulombs. Next question is, after these have been in contact, what will the charge on each sphere be when they are removed or placed back in their original positions? I know that the charge on A will be equal to the charge on B, and that would be the total charge divided by 2. It splits in half because the objects are equal. So it's a negative 2.6 microcoulombs divided by 2. That gives us a negative 1.3 microcoulombs, or we could write it as negative 1.3 times 10 to the power negative 6 coulombs. Next question to answer is, what is the change in charge on A? Now, the change in charge is always calculated by taking the final charge and subtracting the initial charge from it. And the final charge on A is a negative 1.3, and the initial charge was a plus 3.2. So it's negative 1.3 minus 3.2. That gives us a negative 4.5 microcoulomb charge. So the charge there is negative because A gained electrons. So I expect the change in charge on B to be positive 4.5 microcoulombs. So change in charge on B is the final charge on B minus the initial charge on B, which is a negative 1.3 microcoulombs minus a minus 5.8 microcoulombs. So that brings us to a minus 1.3, and technically that's plus 5.8. So it is a 4.5 microcoulomb charge. That's the change in charge, and it's a positive value and the positive means that B lost electrons. The last question we need to answer is the number of electrons that were transferred. So the number of electrons transferred is the change in the charge, and I'm going to use A's charge because it is negative, divided by the charge on, the charge on the electron. So it's minus 4.5 times 10 to the minus 6 divided by minus 1.6 times 10 to the minus 19, and I want the answer to be positive, and I want the exponent of the 10 to be positive as well. So 4.5 exponent negative 6 divided by 1.6 exponent negative 19, and it gives us an answer of the number of electrons 2.8125125 times 10 to the power 13, and that's the number of electrons that were transferred. Example 5 is the last one in this series of videos, and we've got an object with a negative charge of 2.1 picocoulomb and another one with a charge of minus 4.5 picocoulomb. So the first question we need to answer is, in which direction will electrons flow when they're brought into contact? So you need to look for the one with the biggest negative charge. The electrons will flow from the one with the biggest negative charge. So that would be from B to A, because A's got the smallest negative charge. It's got less of an excess of electrons. Second thing we ask ourselves is, what is the total charge on this system? So it's the charge on A plus the charge on B, which is negative 2.1 picocoulomb plus the negative 4.5 picocoulomb, and that gives us a negative 6.6 picocoulomb. If they require you to write that in scientific notation, it is negative 6.6 times 10 to the minus 9 coulomb. Next question is, while they're in contact, charge has the electrons flowed from B to A, so charge has been transferred. What is the charge on each of the objects after they've been separated? So the charge on A would be the same as the charge on B, and that is the total charge divided by 2. So it is the negative 6.6 picocoulomb divided by 2. That brings us to negative 3.3 picocoulomb on each of the objects. Then what is the change in charge on A? Now I know that A has received the electrons, so the change in charge on A should be negative. It's the final charge on A minus the initial charge on A, which is negative 3.3 picocoulomb, negative, now this is a negative 2.1 picocoulomb, and that brings us to, so it's a negative 3.3 picocoulomb plus 2.1 picocoulomb, if you do your mathematics right. So there's a negative 1.2 picocoulomb change in charge, which means that electrons were gained by A. And the change in charge on B, I don't have to calculate it now because I know it should be plus 1.2 picocoulomb. So it should be plus 1.2 picocoulomb because the charge that was lost by B was gained by A. So just to confirm this, the final charge on B minus the initial charge on B, so it is negative 3.3 picocoulomb minus the minus 4.5 picocoulomb. And if you do your mathematics correctly, you'll see that your answer is 1.2. The next thing we need to do is to calculate the number of electrons transferred. That would be the change in charge, and I'm going to use A's values divided by the charge on the electron. So the change in charge is negative 1.2, and a picocoulomb is 10 to the minus 9. Divide that by negative 1.6 times 10 to the negative 19, and we get an answer of 7.5, which is a positive value. 7.5 times 10 to the power, and that would be 10, 9. Right, so just to confirm, the number of electrons is positive because we count a number of things in positive numbers, and we can't have a fraction of electrons, so the exponent of 10 or the power of 10 must also be positive. I hope you found this very useful and that you understand the work after this, watching these videos. Thank you for watching. See you in future again.